Hello, and welcome to Module 5 for SED 513. So far this semester, you have learned about all the different types and approaches to and purposes of program evaluation, how to design an evaluation, and writing evaluation questions. In this module, we will talk through study design. After this module, you will be able to list out a variety of design approaches and how they are linked to specific types of questions. Identify potential threats to the validity of your evaluation and evaluate your design based on two different tiered systems of levels of evidence. The questions you previously wrote will guide you in selecting the appropriate evaluation design. While one approach may be a good match for your questions, there are real-world constraints that may make that design less favorable, such as cost, timeliness, and staff capacity. As future leaders, you must consider all of these together rather than just the question and design match. In this first video segment from IES, they will describe 4 different design categories: descriptive, correlational, quasi-experimental, and randomized control trial. At the end of this segment, there will also be a discussion on the use of multiple approaches.
Evaluation design refers to the data collection processes and analytic methods used to answer your evaluation questions. An evaluation design should be informed by the program goals, logic model, evaluation questions, available resources, and funding requirements. In this chapter, you will learn about 4 broad categories of evaluation design: descriptive designs, correlational designs, quasi-experimental designs, and randomized controlled trials. Often, program evaluation involves more than one or even all of these design categories. Programs often begin as pilot programs, which may be small in scope. If promising evidence is found using descriptive or correlational designs, those programs may be scaled up. To assess whether programs are effective after the initial pilot, more rigorous designs, such as quasi-experimental or experimental designs, may be used. Let's begin by examining what each of these evaluation design categories entails. As each design category is introduced, you will explore whether the design might be used in the case of AMP, and you will be prompted to consider what the design might look like if AMP were scaled up. Next, you will learn how an evaluation may involve multiple design categories. First, let's discuss descriptive designs. As the name implies, this design category involves describing a program by addressing who, what, where, when, and to what extent questions as they relate to the program. A descriptive design can be used to document how a program works, provide feedback on implementation, identify barriers to program success, help determine the best outcomes for assessing program effectiveness, or help clarify program objectives. To get a better sense of what a descriptive evaluation might look like, let's review the AMP example. For the AMP evaluation, let's say that the team wants to document the number of volunteer tutors trained to ensure that there are enough staff to provide after-school homework support to students. The team might even want to know the backgrounds of the students and volunteers who participate in the program. The questions presented here might provide insight into key activities and outputs. Example descriptive design questions include the following: how many volunteer tutors were trained to implement AMP? How many tutoring hours on average did students receive? What are the characteristics of students and volunteers participating in the program? A descriptive design answers descriptive questions. The descriptive design for AMP will help the evaluation team understand whether enough tutors were trained, whether those tutors are meeting with students, and whether the target population of students is being reached. Next, let's look at correlational designs. A correlational design involves identifying a relationship between two variables and determining whether that relationship is statistically meaningful. Correlational analyses do not demonstrate causality. You might learn that X is related to Y, but you cannot confirm that X caused Y in a correlational design. A correlational design can be used to document how program participation relates to outcomes of interest, understand associations between various subgroups and changes in participants' knowledge, skills, and behaviors, or determine how differences in implementation are associated with intended outputs. What about an example of a correlational design? For the AMP evaluation, the team likely wants to know whether there is a relationship between tutors' participation in the AMP training, one of the logic model activities, and their knowledge of effective techniques, one of the logic model short-term outcomes. They might ask the following correlational design question. Did the tutors who participated in AMP training demonstrate an increased knowledge of effective techniques? However, the team will not be able to say that the training caused increased tutor knowledge. A common mistake is using descriptive or correlational designs to say, this intervention caused this to change. Now let's turn to two evaluation designs that can be used to determine if a program is likely to have caused its expected outcomes. Quasi-experimental designs, or QEDs, and randomized controlled trials, or RCTs. Both QEDs and RCTs compare the outcomes of a treatment group who receive the intervention to the outcomes of a comparison group who do not receive the intervention. Consequently, both QEDs and RCTs are often used to answer the same types of evaluation questions. Including a comparison group helps ensure that any changes observed in the treatment group are actually due to the intervention and not to some other cause. In QEDs, individuals are not randomly assigned to groups because of ethical, practical, or other constraints. For example, the AMP funder may require that all students interested in the program be allowed to participate. Because there may be systematic differences between students who participate in the program and those who don't, QEDs use matching or other statistical adjustments to create treatment and comparison groups that are as similar as possible to one another. RCTs involve randomization, a process like a coin toss, to assign individuals to the treatment or comparison group. Using this process virtually ensures that there are no systematic differences between individuals in the treatment and comparison groups. Because of this, RCTs are often referred to as the gold standard for evaluation and are typically held to offer the highest quality evidence of effectiveness of a program. Both QEDs and RCTs can be used to compare differences in outcomes between treatment and comparison groups. They can be used to determine whether a program or intervention is likely to have increased intended outcomes of participants on average, or to evaluate how confident an evaluation team can be that a program or intervention has caused changes in outcomes that matter to the team. Let's look at an example of each to help illustrate the differences. First, an example of a QED. What if the AMP evaluation team wants to understand whether the program has had an effect on students' readiness for high school math? In this case, the team can stretch this example to include a set of partner schools that serve similar populations of students. Because these schools are not using AMP, they provide a potential comparison group. These schools are using a business-as-usual condition in which no new interventions or programs are offered. However, the partner schools that are not using AMP may differ from the AMP schools in many ways. For instance, they may differ in the characteristics of the students they serve, such as the percentage of students with individualized education programs, or the average student achievement. The characteristics of teachers, such as the average years of teaching experience, or other factors, such as average teacher salary. To begin the process of designing a high-quality evaluation, the AMP evaluation team should gather data about the student and teacher populations at the schools. The team can use these data to begin to understand how similar the AMP and non-AMP schools, students, and teachers are to one another across a number of factors. The team can also use the data in statistical models to adjust, at least in part, any differences between the treatment and comparison groups that might be related to the outcomes the team is most interested in. This design will help the team address the midterm outcome about readiness for high school math. An example QED question is, did participation in AMP have an effect on grade 9 students' readiness for high school math as measured by a math placement test? A QED like this one is appealing because the evaluation team can use existing data from schools that did and did not implement AMP to answer the evaluation question. In comparison, an RCT would require identifying a set of schools that agree to be randomly assigned to either implement or not implement AMP. However, as you will explore further in Chapter 3, evidence from a well-designed, well-executed QED is not as strong as evidence from a successful RCT. Now for an RCT example. Let's suppose that the AMP evaluation team has the funding and support to roll out the program to only a limited number of students in a subset of schools. Students in some schools will be randomly assigned to use AMP, and students in other schools will be randomly assigned to continue with the business-as-usual condition, in which no after-school program is offered. This design, if well executed, generates the strongest possible evidence for the team as it works to evaluate whether AMP participation has decreased the number of issues in the community. An example RCT question is, did participation in AMP cause a decrease in the number of community issues among students in the program? An RCT like this one can help the evaluation team understand whether AMP participation, in addition to other factors, caused a decrease in the number of community issues. In this way, the team can feel very confident that the evaluation results are due to AMP and not to other unobserved factors that might influence the decrease in community issues. Importantly, because of random assignment, the students who participate in AMP and the students who don't participate in AMP are likely to be similar in observable ways, such as student achievement, as well as in unobservable ways, such as family support. In a QED, unobservable differences are more likely. For instance, students who participate in AMP might have more family support than students who don't participate in AMP. Such support is difficult to measure but influences student outcomes. For this reason, a well-designed RCT gives the evaluation team stronger evidence of the causal effects of AMP than a QED does. One word of caution: participants who are assigned to a treatment group may not always actually participate in an intervention, as some interventions are optional. For instance, AMP is a program at the school and is optional for students to participate. All eligible students at the school are still assigned to the treatment group, but some may choose to not participate in AMP. It is important to account for this in an analysis. The simplest way to do so is to look at the effect of intent to treat, where all students assigned to the intervention are examined, regardless of whether they participated in the intervention. Another way is to look at the effect of treatment on the treated, where all students who actually did or did not participate in the intervention are examined.
In example 1, a state education agency offers training to schools on positive behavior interventions and supports, PBIS, in an effort to decrease rates of student suspensions. 30 schools volunteer and attend the training. These schools implement school-wide PBIS systems the following year with ongoing support from the state education agency. The agency wants to determine whether the training and subsequent implementation of school-wide PBIS were successful. The agency compares the suspension rates of the 30 participating schools to 30 schools that did not participate, but are statistically similar in racial, ethnic, minority composition, socioeconomic status, and prior suspension rates. Which design is described? A. Descriptive design. B. Correlational design. C. Quasi-experimental design, or QED. Or D. Randomized control trial, or RCT.
The answer to example 1 is C, or a quasi-experimental design. The key here is that the treatment group and the control group are statistically similar, but random assignment was not used to determine the groups.
In example 2, a school district receives a free year subscription to an online program that provides curricular materials and literacy. After the free year has concluded, district leaders evaluate the program to determine whether to pay for the subscription. The leaders conduct a literature review to identify and summarize the results of previous studies of the program and similar programs. They also administer a survey to assess how frequently reading teachers used the materials over the past year, as well as how the teachers perceive the value of the program. Finally, the leaders conduct a focus group with a small sample of teachers to discover how they implemented the online literacy materials into classroom instruction. Which design is described? A. Descriptive design. B. Correlational design. C. Quasi-experimental design, or QED. Or D. Randomized controlled trial, or RCT.
The answer to example 2 is A, or a descriptive design. There are no treatment and comparison groups, and the analyses are limited to assessing frequencies and perceptions related to the online program.
In example 3, state education agency administrators consider providing additional funding for school counselor positions. They examine school-level data on student-to-counselor ratios and find considerable variation across the state. The administrators want to determine how the availability of counselors is related to student behavioral outcomes. They find that schools with lower student-to-counselor ratios have higher rates of attendance and college-bound students. Even when they restrict their sample to Title I schools, these relationships persist. Which design is described? A. Descriptive design. B. Correlational design. C. Quasi-experimental design, or QED. Or D. Randomized controlled trial, or RCT.
The answer to example 3 is B, or a correlational design. Here, the administrators examine how one variable, student-to-counselor ratios, relates to other variables, attendance and college-bound students. This approach takes the evaluation a step further than a descriptive design, but again, there are no treatment and comparison groups.
In example 4, a large school district wins a grant to fund an elementary math intervention in 10 schools. The intervention provides after-school math tutors as well as professional development activities for math teachers in each of the participating schools. The district invites all of its elementary schools to apply for the funding. 20 schools apply, so the district conducts a lottery to determine which 10 schools receive the intervention. After the intervention has been implemented, the district compares math achievement in the 10 schools that received the intervention to math achievement in the 10 schools that applied but were not chosen in the lottery. Which design is described? A. Descriptive design, B. Correlational design, C. Quasi-experimental design or QED, or D. Randomized controlled trial or RCT.
Finally, the answer to example 4 is D, or a randomized controlled trial. In this case, the district conducts a lottery to determine which schools receive the intervention. Thus, the evaluation includes randomly assigned treatment and comparison groups. In practice, comprehensive program evaluation usually involves multiple evaluation designs. The early stages of an evaluation may generate more ideas. Answering an initial set of questions about a program often sparks additional questions. In these instances, a descriptive design may be most appropriate. On the other hand, the later stages of an evaluation often provide stronger evidence of the impact of a program, as the questions of interest may be more refined. At this point in the evaluation, a QED or RCT may best address the evaluation questions.
In the next video segment, IES will present information on threats to validity. Anyone can make a claim about a program or its outcomes, but minimizing threats to validity can increase the likelihood and confidence that those claims hold true. There are two main types of validity: internal validity and external validity. You will need to think through possible threats to validity of potential statements for the program evaluation that you are planning.
In this chapter, you will learn about threats to validity in evaluation design. The purpose of program evaluation is to provide answers to questions about a program. Anyone can make unsupported claims about a program, but through the process of systematic evaluation and the intentional use of rigorous evaluation designs, you can answer your questions with confidence. Evaluators refer to the concept of validity when discussing how confident they are in the claims of an evaluation. Validity refers to the extent to which the results of an evaluation are supportable given the methods used. Validity applies to the evaluation design, analytic methods, and data collection. Ultimately, valid claims are sound ones. You should examine threats to validity, factors that might undermine the soundness of your claims, regardless of what your evaluation design is or whether you ask process or outcome evaluation questions. Minimizing threats to validity is an essential part of any evaluation. This chapter will provide you with a basic understanding about threats to validity so that you can be better equipped to understand and use evaluation. Additionally, this chapter will help you make sounder interpretations of evaluation results with an awareness of their limitations. There are two main types of validity: internal validity and external validity. In this chapter, you will learn the difference between the two types and see examples of each. Both can be threatened in many ways, but this chapter focuses only on the most common ways. First, let's look at internal validity, which relates to the results of an evaluation. At its most basic, internal validity involves asking whether the claims about the characteristics, or effectiveness of a program are true. Internal validity can be threatened by problems in the design, such as not controlling for key variables in a correlational or quasi-experimental design, or by problems in data collection or analysis, such as not properly accounting for missing data. There are many threats to internal validity in program evaluation, but two of the most common threats are attrition and selection bias. Let's review these two common threats to internal validity. Attrition happens when participants leave an evaluation after it begins, but before it concludes. Attrition hinders an understanding of the outcomes of a program because there are often no data on participants who leave, producing an incomplete picture of the impact of the program on the leavers. Let's consider the AMP example. Remember that AMP is a fictitious after-school program to improve student math achievement and graduation rates. An evaluation of AMP might, among other things, estimate the program's effect on student dropout rates. But what if 15% of the students who were AMP participants at the start of the evaluation moved to other districts before graduation and were not included in the final analyses? This 15% attrition rate would threaten the internal validity of the evaluation. Research has shown that highly mobile students are more likely to drop out of school. Therefore, if the evaluation finds that AMP has an effect on dropout prevention, but that 15% of students in AMP moved to different districts, didn't finish the program, and were not included in the final analysis, the evaluation team should be concerned that this effect has been overestimated. Selection bias happens when the treatment group differs from the comparison group in a meaningful way that is related to the outcomes of interest. Again, let's consider this threat in relation to the AMP example. Say that a different district rolls out a program similar to AMP and allows any of its 6 middle schools to participate. 3 schools chose to implement the program, and the district wants to conduct an evaluation to compare the outcomes for those 3 schools to the outcomes for the 3 schools not implementing the program. This case represents a threat to internal validity due to selection bias. Meaningful differences between the treatment and comparison schools are likely. For instance, the schools that participate may be more likely to have staff that support program implementation, or they may serve student populations that receive more family support to complete homework assignments. As a result, the treatment group may not be representative of the target population, possibly leading to overly positive results. Now let's discuss external validity, or generalizability. External validity is the extent to which the results of an evaluation may be generalized to different contexts, such as other populations or organizations. An evaluation can have strong internal validity, but not have external validity. However, an evaluation must have internal validity in order to have external validity. Next, let's look at contextual factors, multiple treatments, and the Hawthorne effect as common threats to external validity. Perhaps the most common way in which an evaluation lacks external validity or generalizability is different contextual factors between the sample in the evaluation and a population to which one wants to generalize. Consider again the AMP example. Let's say that AMP was implemented 15 years ago in a large urban district in the Northeast United States. What if leaders in a rural district wished to implement AMP today? The leaders should be very careful in generalizing conclusions from the original AMP to the rural district. Because the time and place are so different, the strategies that were implemented effectively in the original context may not work in the second context. Multiple treatments is also a threat to external validity, whereby external factors, in addition to the program, may cause the evaluation to detect a different effect than it would if the external factors were not present. For instance, perhaps AMP is being implemented in a district where a new math curriculum is also being implemented. In this example, AMP is the program being evaluated, and a new math curriculum is an external factor not associated with AMP. Thus, a combination of the middle school's efforts to implement AMP and the new math curriculum could lead to effects that are not reproducible by either treatment alone. If a school district implements AMP in the future, that district could see a much different effect, since they did not have the same external factors. Another example is called the Hawthorne effect, whereby individuals act differently because they know they are taking part in an evaluation. Sometimes, being studied can influence outcomes. What if AMP were a high-profile program with very visible funders and media coverage? This could lead to increased scrutiny, pressure, and praise, all of which might lead school staff and students to perform better than they would otherwise. Ultimately, the high-profile nature of the program could cause it to appear more effective than it would be without the visible funders and media coverage. In other words, some of the observed effects would be due to factors other than the evaluation of the actual program. If AMP were implemented later with less fanfare, it might lead to less positive outcomes. This is an example of the Hawthorne effect. Many aspects of an evaluation may limit its validity. This chapter has provided a brief overview of some ways in which validity may be threatened. For now, keep in mind that you can assess the validity of an evaluation in terms of internal validity, or the extent to which results are justified based on the evidence gathered, including any relative claims of cause and effect, and external validity, or the extent to which results may be generalized to other contexts.
After you have thought through the type of design and identified potential threats to validity, you will need to think through what evidence of effectiveness will look like for your project. There are two different systems utilized at the federal level that can be used to look at levels of evidence: Every Student Succeeds Act, or ESSA, and the What Works Clearinghouse, or WWC, design standards. The ESSA system breaks down evidence into 4 tiers, while the WWC looks at evidence as meeting with or without reservations, or not meeting the standards at all. The strength of evidence you require will determine the level of rigor needed in your design. Oftentimes, with program evaluation, lower tiers of evidence are needed, often level 4, demonstrating a rationale, or level 3, having promising evidence. If you're interested in learning more about those specific levels of evidence, you can look at the IES Program Evaluation Toolkit and review Module 3, Chapter 3. Different designs and analytical strategies can lead to levels of evidence that are strong, moderate, or promising. Generally speaking, in terms of design, an RCT, also known as the gold standard, is required for classifying evidence as strong. Quasi-experimental designs, or QEDs, can result in moderate evidence, and descriptive or correlational studies can show promising evidence. As I stated earlier, these two systems are used for classifying strength of evidence for federal grant dollars and large-scale evaluations. Often for local program evaluation, you are looking for a description of impact of an intervention or initiative, or looking for relationships between outcomes and programs rather than looking for strong rigor in design and analysis. In this module, you have heard a lot of information on design types, consideration of threats to validity in design and analysis, and systems for classifying evidence of effectiveness. We look forward to seeing how your team plans to design the evaluation for your proposal moving forward.